Welcome. If you are old enough to remember a time before Wi-Fi, smartphones, and the internet, then your first introduction to computers may very well have been HAL 9000, who came from the 1968 film 2001: A Space Odyssey. HAL had a level of artificial intelligence that doesn't even exist today. And it tried to kill its entire crew.
Open the pod bay doors, Hal.
I'm sorry, Dave. I'm afraid I can't do that.
So if HAL left you with a distrust and general fear of computers, I don't blame you. But we need to remember that was science fiction, and that a computer today is simply an adding machine that can store data. So today we're going to talk about how a computer actually works, and move from fiction to fact. All computers work on exactly the same model. They require human input through devices like touchscreens, keyboards, and your mouse. Even if a computer is reading data from a database, that data needs to be created by human beings. Computers are like teenagers. They don't think for themselves. They rely exclusively on input they receive in order to operate. Without any input, the computer simply does not work. No teenager has ever cleaned their room without input. The main difference with a computer is you only have to tell it once. Once it's received as input, it needs to process it in some way. It makes use of its central processing unit, or CPU, and its memory to do this. It changes raw data into useful information. This is why the term information systems was coined. The last step in the process is to output the information to the computer screen, the printer, or even the speakers. Again, if there is no output, the computer does not function. It's important to mention that the list of input and output devices I have mentioned is by no means exhaustive. The computer is also capable of storing information onto their hard drives. This allows the data to be retrieved for future use. A lack of storage doesn't cause a breakdown in the model, but certainly limits the functionality of the computer. Based on this model, we can see that smartphones, gaming consoles, and tablets all fall into the category of computers. Now that we have seen the importance of input, we must mention input quality. If you try and cook with garbage, you're going to be eating garbage. No amount of culinary skill will ever change that fact. In the same way, there is a computer principle that was coined in 1965. Garbage in, garbage out. If a computer receives incorrect input, you're going to receive incorrect output. So when a computer doesn't do what you're expecting, it usually means you haven't given it the right input. In order to understand computers, we must first understand their language. Computers make use of binary. Binary is a series of off or on signals. They use these signals to communicate as well as store data. So, what is binary? Let's start with a numbering system that everybody knows, decimal. Let's go back to primary school. The word decimal comes from the Latin word decimus, meaning tenth. So decimal has 10 digits, 0 to 9. Each position in a decimal number has a value. We start with units of 1. Our next position is multiplied by 10, as we have 10 digits, giving us tens, followed by hundreds, thousands, and so on. So if we take a number like 9,875, it is made up of 9 thousands, 8 hundreds, 7 tens, and 5 units. This seems rather obvious, but it will make sense when we change to binary. So let's talk about binary. Binary starts with the word bi, meaning two, which is why a bicycle has 2 wheels. Like decimal, every position in a binary number has a value. Again, we start with units of 1. The next position is multiplied by 2 because we have 2 digits. So we get values like 1, 2, 4, 8, 16, 32, 64, and so on. These numbers pop up again and again in computing. The binary number of 1011 has a value of 18, no 4s, 12, 11. 1011 in binary is therefore equivalent to 11 in decimal. So clearly, binary can be used for calculations. It is also used to store letters, as every letter and every punctuation mark has its own unique binary code. Binary is not limited to storing letters or doing calculations. It is also used for working with pictures, music, and video. These media items can all be expressed as numbers, and therefore as binary. Music is made up of vibrations, which can be plotted on a graph. These points are represented by numbers. Pictures are made up of picture elements called pixels. The color and position of each pixel is stored as a number. The more pixels a picture contains, the better the quality of the image. A high-definition image typically has a little over 2 million pixels, with each requiring a color and a position. Pictures therefore have larger file sizes than documents. Videos are a series of pictures and sound. They show upwards of 30 pictures per second. This is why video files are so large. Now let's talk about how computers process and transmit these binary signals. Our voices are made up of analog waves, which can have any value. This is why my voice sounds unique, because my analog pattern differs from yours. Digital signals, like binary, have two possible values. Inside computers, they are either plus 5 volts DC or minus 5 volts DC. When you hear a digital voice on a telephone, you'll notice it's quite flat because they don't have the same range of values available to it that an analog wave does. When an electrical signal is sent within a computer, plus 5 volts represents 1 and minus 5 volts represents 0. And that is how we transmit binary. Computers cannot think for themselves, but they can make decisions based on their input. It uses something called logic gates that usually have two signals giving 4 possible options. If we look at the AND gate, for example, if both A and B are 1, then the result AB is also 1. If either one of those or both of them are 0, then AB is 0. So if I tell you 2 lies, I've lied to you. If I tell you a truth and a lie, I've lied to you. Only if I've told you 2 truths have I actually been truthful. There are 7 different logic gates. The OR gate, for example, returns 1 if either or both are 1. The NOT gate just changes the value of the signal. Combining these 7 gates allows the computer to perform logic calculations using binary signals. So if computers are so simple, why are they so powerful? The answer is they can do these simple calculations at astonishing speeds. A modern processor running at 5 gigahertz can perform 5 billion calculations every single second. To give some context to how large that number actually is, it would take a stopwatch 158.5 years to reach 5 billion seconds. The fastest computer in the world, the fastest supercomputer, runs at 200 petaflops. That is 200 quadrillion floating point calculations per second. That's 200 followed by 17 zeros. That is a number that just makes my brain hurt. Hopefully you have seen that computers are just adding machines that can store and retrieve data. When you realize how simple they are, you are less likely to be intimidated and fearful of them. Remember that computers are totally reliant on human input. So for now, we're in charge.